Lesson 11.3, areas of polygons. Today we're kind of trying to figure out what is the area of a given polygon, whether it be like this one, a hexagon, or maybe something more complex, a duodecagon. And the idea comes back to triangles. Let's start with, okay, what is the center? So if you think about a polygon, the center's in the middle, and the center would be the distance the center is calculated by finding the distance between each of these points, namely the vertices. If those distances are the same, that's the center. So the middle, I'm going to put quotes around the word middle because that's not a mathematical definition of the polygon. The distances to the vertex have to be congruent. Okay, radius. What is the radius? Those lines that I drew up there, those are the radiuses, the radii as it were. So the segment between the center and the vertex. Clarification here, all of the polygons that we're drawing are called regular polygons. And it means, if you recall from chapter 7, that we have congruent sides and we have congruent angles. What is the apothem of a regular polygon? The apothem is another distance. Let me draw another. This time I'll draw a hexagon. And the apothem is the distance from the center to perpendicular to the side. So we can draw many of these distances. They are, in essence, the smallest radius. If you think about all these different lines that we could draw to the edge, the apothem is the shortest one. So it is the segment from the center perpendicular to the edge. And finally, what is the central angle? Let's draw a four-sided shape this time, aka a square. All the angles again have to be the same, and all the sides have to be the same, right? That's what it means to be regular. The central angle would be defined as the angle between two consecutive radii. All right, so this is the angle that is centered between two consecutive radii. With that, let's get down to how do we find the areas. These are the pieces that we need to calculate areas. We're going to start with four-sided figures. Specifically, not rectangles, but rather rhombuses and kites. How do I find the area of a rhombus? The area of the rhombus, if you think about it, is kind of circumscribed by this rectangle. In other words, if we take the diagonal, D1, and then the other diagonal, D2, and if we move those diagonals from the center off to the edge, again, to build that rectangle, then what we can do is, you can see we have length times width is the area of an object. So in essence, the area of that rectangle would be D1 times D2. And then we can see that each of these triangles measures half of that little box that it encompasses. So that's why the area is formula 1/2 times your two diagonals. And that works regardless of whichever rectangle, whichever rhombus or kite you're working with. Okay? Second of all, how do I find the area then of something with more than 4 sides? So here, instead of 4, we have 6 sides, aka a hexagon. The first thing that we should observe is that in a hexagon, if I take my central angles, I end up with 6 triangles that are all identical. And we can line those up down here at the bottom. I'm drawing them a little bit smaller so they fit. And what you should notice about these 6 triangles is that I can fit them in a rectangle. And the length of that rectangle is down here at the bottom, perimeter, and then the height. What is the height of that? The height is the distance A. And that A is what we refer to as the apothem. Okay? And remember, each triangle occupies half of the rectangle it fits in. So we have 1/2 times the apothem times the perimeter. So A and P in this case stand for apothem or perimeter. And remember, one way to remember to find the perimeter is just take the side length and multiply by how many sides you have. So either formula works. Let's use this now in these different shapes. Here we have a rhombus. So again, we can build the rectangle around it. And we see that the height of that is 20. So the area is 1/2 times 20, and the width of it is 14. If I multiply those out, I get 140 square inches. Number 2. Same thing. Again, draw the rectangle around it. And notice that we have 8. Notice that we have 4. So area equals 1/2 times 8 times 4. 16 square centimeters. If I have a polygon with 8 sides, how do I find the central angle? So again, this is if you want to draw a octagonal shape, it's a stop sign. And the central angle is this little angle here. Well, we know that if I add up all of them together, all 8 of them, I will get 360 degrees. So if I take 360 divided by 8, I can get 90. Whoops, 45 degrees. And likewise, if they tell me that the central angle is 40 and ask how many sides, it's kind of the opposite of that question that we just did. So we know that the formula is 360 divided by the number of sides gets me the degrees. And you recall from previous chapters that this is kind of like a proportion. And we know that our cross products work. So I can multiply those two and those two. So we know that 360 is equal to n times the degrees. So in essence, if you know the degrees, just divide by the degrees, right? Because we know that there's 40. So just take 360 divided by 40, and that's going to give you n. So in this case, n is 9. 9 sides. All right, now for something a little bit more complex. Pentagon, 5 sides, right? N equals 5. And I have a radius of 4 and a side length of 3. Very difficult to visualize without a picture, so I recommend sketch it as best you can, a pentagon. You're going to be sketching a lot of these during this chapter. Pentagons, hexagons, those kinds of things. We don't draw septagons too much. All right, and again, here is my radius, is 4, and 3 is my side length. So the first thing it says is find the apothem, and the apothem is this distance here, perpendicular. So it's helpful if you draw that triangle outside, a little bit larger. Again, we know that hypotenuse is 4. Be careful, this shorter edge is 1.5. Now the question is, what is the apothem? Called A right there. Well, Pythagoras should help us solve that. So we know that 4 squared has to equal 1.5 squared plus A squared. Solving for A, we have to take a square root. Well, let's just say A squared for now. I have to take 16 minus 2.25. So again, if you square 4 and square 1.5, and then subtract the 1.5, and now we have to take a square root of that mess. This is not going to get us a nice number, and that's okay. We're going to approximate this out to, I think it's 3.71, if I'm correct. Let me do that on my calculator. Yeah, 3.71. I'm going to go out to the nearest hundredth. Now to find the area, capital A, I have to take 1/2 times the apothem of 3.71 times the perimeter. What is the distance all the way around? So hopefully you got 15. Multiply those out. And this time I'm only going to round to the nearest 10th. So times 15. 27.8 inches squared. All right. And for a hexagon, this one is a little bit tricky because it feels like it doesn't give you enough information. All it gives us is the apothem. So we don't have the perimeter. And to get the perimeter, we need to find the length of one side. The radius we don't need to find in this case. Here we go. Apothem is 10, and that's all we're given. Again, look for the triangle. So that's kind of why they ask you to find the radius, is so that you build that little triangle. Now, one of the things from chapter 9 is that if you only know the side length, one side length is 10 like that, you can't solve this problem. You can't find the sides. Specifically, we are interested in this side here. Okay, how do I go from here? to here, to that side. Well, to do that, you have to figure out one of these angles. And so this is why central angle becomes important. How do I find that angle inside here? So remember, we take 360 divided by the number of sides. In this case, 4 would give us 90. So that central angle in that problem is 90 degrees. Well, what's the central angle in my problem? So 360 divided by 6 is 60. Be careful. The central angle is from here to here, correct? So this is 60. This angle here is not 60. In fact, if you draw the central angle there, you can see that it's exactly half. So we need to take 60 divided by 2, 30 degrees is what is in my triangle. Now remember, 30 degrees makes this a special triangle. 30, 90, 60. How do I get the short leg from the long leg? Again, going back to chapter 9. Well, clearly we have to divide. In this case, remember this is a 1, 2 radical 3. So divide by radical 3. It's called the side x. So x is equal to 10 divided by radical 3. Now I could multiply by radical 3 over radical 3 as we did in the past. In this case, I need to know the value. And let's round this off to the nearest hundredth again. So 10 divided by radical 3. And my calculator says 5.78 approximately centimeters, I think. Units. Now to get the area. Oh, if I wanted to report this side here, I would double it, so times by 2. And that would be something like 11.5 4 or 5.5 actually. Okay. I think if you use the 8, you'd probably get a 5.6. All right. Now to get the area, we need to take 1/2 times the apothem, which is 10 times the side length. The side length is this whole distance here. And that is twice 5.78. So if I twice that, I get 11.56. And I get 57.8 units. Oops. Squared. All right, well, hopefully that helps you work